half, that's marginal. The chance I eat cornflakes is a different probability, and that's marginal. The chance that I do both, or either one, that's joint probability. Conditional, those are probabilities where we're talking about one occurring given that another has occurred. So that's important to independence. Given I eat cornflakes, the chance that I get heads is 1/2. So that's a conditional probability, the probability of heads given some information. These probabilities are most important for business because it's how we update our beliefs. So I can say, what's the probability that a product will be successful? Maybe that's 50%. But then we can say, what's the probability that a product is successful given it has had a successful test market? Or given that consumer research suggests it's demanded, or given that our competitor has a successful product in this area. There are lots of information events that can occur that would influence our probability expectations. And so conditional probabilities are the way we incorporate that information into specific probabilities. So we'll want to be able to turn marginal and joint into conditional and vice versa. So in terms of mathematical notation, we would say marginal is the probability of an event A, and then joint is going to be some expression with multiple letters, right? A or B, A and B, A or B and C or D, etc. So no matter what, you need 2 or more letters to express it, and that makes it joint. In conditional, it looks exactly like this. We say the probability of an event given some other event. So we have some information, B, that we know. It's an event that has occurred, or we believe, occur either hypothetically or in reality. And knowing that B has occurred, either hypothetically or really, implies something for A. So A given B is how we read that, and it means the probability of A given the information contained in B. If we want to convert between the different probabilities, we need some specific formulas. So the first is, under what circumstances can I simply add probabilities? So I think, what's the chance that I know, let's say the chance I eat cornflakes is 1/2, and the chance that I get heads is 1/2. Well, when might I add those and get 1? And the only time you can do that is when you have mutually exclusive events. So if you have mutually exclusive events, then you can use this. You can use an addition rule where you just add up the probabilities. So, for example, let's say we have a belief that the Groupon IPO will happen this year and be successful, a 60% chance. Well, the probability that it will be successful or won't be successful, that's a mutually exclusive set. And so we can simply add the probabilities. 0.6 plus 0.4 equals 1. Note that means this is collectively exhaustive. If you have a mutually exclusive set where the sum of the probabilities are 1, that's also collectively exhaustive. So it's a mutually exclusive and collectively exhaustive set. If it's not mutually exclusive, we have to use a different addition rule. So you have to subtract off the probability that both occur, which would of course be 0 if they were mutually exclusive. So that's what's showing here. If I have a multiplication rule, so when would I say 1/2 times 1/2 equals 1/4 for my coins and cornflakes? Well, that would be if the two events are independent. So the answer is not 1/4. Okay, and it also is for and. So that has to be that A and B occur, and if they're independent. So in my case, the probability that I get heads and eat cornflakes is 1/4 because I'm interested in heads and cornflakes. Those events are independent. We talked about that earlier, so we can just multiply. In terms of things not independent, let's think about probability of Groupon going public and Living Social, a competitor, being profitable this year. So we can, if they were independent, we would say 0.6 chance of Groupon, 0.8 living social being profitable. You get 0.48. The problem with this is that it's not likely that in a company in the consumer advertising space, their profits will be independent of Groupon, right? Because they both are sort of in the same business. Things that are good for Groupon are generally good for Living Social, and so they should move together. So we can think about what's the probability of Groupon going public given Living Social is profitable. And we can also think about the chance that both happen. So it'd be 0.48 if they were independent. What if the chance that they both happen is actually 0.5, not 0.48? So it's slightly higher than we would expect. Well, that would mean, based on the definition of conditional probability, that the chance of a Groupon IPO given a Living Social profitable is actually 0.625. So this profitability assumption, right, if we hypothesize that this would happen, it would imply that the Groupon IPO would become more likely by 2.5%. So the probability of Groupon is updated by this information, whether this has happened or not. But we can imagine, well, what if we receive news that Living Social is profitable? Well, then that should update our beliefs about a Groupon a Groupon offering being successful. Okay, so let's think real quick about some sets of events. So if I have a set of two things, a product sells 1 million units or more, and B, a product sells less than 1 million units, is this mutually exclusive and collectively exhaustive? So at most, can one happen? Correct. These cannot both happen, so at most one can happen. Is it collectively exhaustive? Does at least one of those have to happen? Yes. One or the other is going to happen. So one of those is going to be true, so it's collectively exhaustive as well. So what's the chance that one or the other will happen? Probability A or B? Well, 100%, right? We're going to get one or the other. And that always happens when you have a mutually exclusive, collectively exhaustive set. If it's both, the chance that one or the other, like an or list of all the different events will be, the probability of something happening from that list will be exactly 1. Of the 5 people in my work group, no one is laid off, or B, 1 person is laid off. So I've got 2 events. Are those independent? The answer to that is no, right? If I knew that 1 person was laid off, what's my belief about the probability of A? Well, it's not going to be the same, right? In fact, the probability of A given B is 0. Right? If 1 person is laid off, the chance that no one is laid off is 0. So probability of A and B, that's going to be 0. And that's, if I go back to the multiplication rule, if I don't have independence, then you have to use an updated rule where instead of probability of A times probability of B, you would say probability of A given B times probability of B. Okay, so when I come back, we will do how to convert between these different types of probabilities using a contingency table.